Example 7.2. A steam power plant is proposed to operate between pressures of 20 kilopascal and 2.4 megapascal with a maximum temperature of 500 degrees Celsius. Find the maximum efficiency in the power cycle. So we have the given 2.4 megapascal with a maximum temperature of 500 degrees Celsius. So we have to find it in the steam table. So it is in the table 3 in the saturated vapor. So here are the values for 2.4 megapascal at 500 degrees Celsius. The enthalpy is equals to 3,462.8 kilojoules per kilogram, and the S1 is equals to 7.3438 kilojoules per kilogram Kelvin. So, and also we have to find from the steam table 20 kilopascal. So 20 kilopascal is equivalent of 0.02 megapascal. So in the steam table, in the table 2, 20 kilopascal or 0.02 megapascal. So at 20 kilopascal, the HF is equals to 251.4 kilojoules per kilogram. HFG is equals to 2357.54 kilojoules per kilogram. SF is equals to 0.832 kilojoules per kilogram. And the SFG is equals to 7.075 kilojoules per kilogram. So obviously 2.4 megapascal is the high pressure and 20 kilopascal is the low pressure. So we have to solve for the pump work. So we all know that V is equals to 1 over rho. So pump work is, we can use this equation for pump work equation. So volume times P4 minus P3 is, so substitute the given values. So 0.001 times the high pressure in 2.4 megapascal converted into kilopascal, 2400, minus the low pressure P3 is equals to 20 kilopascal. So we have the pump work is equals to 2.38 kilojoules per kilogram. So we can also solve for the H4 is equals to H3 plus pump work. It is derived from the pump work equation. H4 minus H3 is equals to pump work. So H4 is equals to H3 plus the pump work. So substitute the given values to 251.4 kilojoules per kilogram plus the pump work 2.38. The H4 is equals to 253.78 kilojoules per kilogram. So solving for the heat input, so heat added is, you can use this equation. Heat added is equals to H1 minus H4. So we have the given values 3,462.8 kilojoules per kilogram minus the H4 2,253.78. So the heat added is equals to 3,209.02 kilojoules per kilogram. So we all know that the S1 is equals to S2 and S1 is equals to this. So we can use this equation is S1 equals SF plus X2 SFG, or SG minus SF. So to get the X, substitute the given values. So 7.3438 equals the SF 0.832 plus the SFG 7.075 and the X. So we can solve it in the calculator. So the X2 would be 0.9204, and also we can solve for the H2 using the formula HF plus X times HFG. So enthalpy is equals to 251.4 plus the X 0.9204 times the HFG 2357.54. So we have the H2 is equals to 2421.27 kilojoules per kilogram. So solving for the work output from the turbine, so turbine work is equals to H1 minus H2, so 3462.8 kilojoules per kilogram minus 2421.27 kilojoules per kilogram. So we have the turbine work of 1041.53 kilojoules per kilogram. So we can now solve for the efficiency. So here is the thermal efficiency of a simple Rankine sample. We can solve this. So the efficiency is equals to turbine work minus pump work over the heat added. So total, so 1041.53 minus 2.39 divided by 3209.01. So we have the efficiency of 0.324, or in percent 32.4%. Thank you, sir. That's all.